I said, all right, well, can I turn it to polynomial? Answer, Tong? No. I might think about factoring it, which would be a super cool way to get around this mess. I got no factors. Okay, Marie, I might set the bottom or top equal to u. If I set the bottom equal to u, which would be the logical choice, probably, I would get u equals x squared plus 1. Du, therefore, equals 2x dx. I don't think I can make the top 2x dx. Similar thing would happen if I did it at the top. So that's problematic. I'm going to introduce to you another way to do this problem that you actually know how to do already, but you don't know you know how to do it yet. Ready? Mr. Dietz, this says this divided by this. How about we divide it? What? X squared plus 0x plus 1 into x squared plus x plus 1. You guys remember how I do this? Your last year teacher's going to be so disappointed. Wait when I tell him. Okay, Mr. Dietz, the fortunate part about this is it's easy. Especially remember law and division from 3rd grade or 4th grade, which you don't remember, but that's okay. But we can still do this. Because it's not that bad, because we teach it to 3rd graders in like 2 minutes. So therefore, I can teach it to you at least 5. Ready? What times x squared gives me x squared? 1. Thank you. Now I got to multiply that through and make sure get rid of everything I get by putting a 1 in there, right? 1 times this, what do I get? So 1 times this is x squared. 1 times this would be plus 0x.
Do you have to keep the x in there? Or the 0?
I do have to, just because of placeholder. It works like if I take 101 and divide it into 909, if I just get rid of this 0 because it's really bothered me, I make this 11 and 909, I get the same answer? No. You would get 9 doing it this way. This way you would get, 90-something-ish, right?
Yeah.
So that's why we have to keep track. Remember, you got to plug that in. I should say remember, but we did talk about it last week. So you got to put any place you have a gap, either in this, in the numerator or denominator, you have to put in zeros to make sure you don't make a mistake. Okay? All right. 1 times 1 is 1. Now, I said the most important rule, and Hummel liked this rule last year, so let's see if you remembers it this year. What do I do next? For sure, 100% have to do before I think about anything else. Flippy the sign. Yes, flippy the sign. Change all the signs right away. Immediately change all the signs before you forget. And I got x plus 0 with me so far.
So you change the signs of that.
Yes. What I'm doing is subtracting them, but I find if I put a minus sign out here, everybody does it wrong. So I don't say flippy the signs, but since she said it, I'll go with it. Flippy all the signs. Like the moment you do this, change every single one of the signs immediately to figure out what you got left over. All right, Mr. Dietz, what times x squared gives me x? So what was that?
What times x squared?
What times x squared gives me x? It'd be 1 over x, but don't worry about it. It's hard to do, right? So therefore, we would stop and write this as a fraction. X over x squared plus 1. So far, so good? Except for the rest.
So you take the x and then do x over then the original.
Right. It's your remainder, right? Whatever you got left divided by that stuff on the left is your answer, right? All right. So why do this? Because all I did is divide. I haven't actually done any integrating at all. But think about it. Now I'm going to integrate instead 1 plus x over x squared plus 1 because this is the same as this, right? And can I do that? Yes, I can. What's the integral of 1? Raise its power by 1. Divide by 1. So it'd be x, wouldn't it?
Oh, yeah.
Derivative of x is 1, right? So integral will be, okay. Plus, oh no, I have to think about this one though. But fear not, because Mr. Tong is going to tell us what to do. U substitution. U is going to equal to what? The correct answer is U is never equal to x. You know why? Because all it does is change U to x. Is not really a waste of time. We'll make it the bottom one. Okay? So U equals x squared plus 1. So du, therefore, equals 2x dx. Any way I can make the top equal 2x. I can, so now I can finish this problem. I'm going to lift it up a little bit. Whoop. Whoop. So this is equal to x plus the integral of, I've got 1 over x squared plus 1, 2x dx. In order to do that, I have to put a 1/2 out in front. Because I needed a 2. And so this becomes x plus 1/2 integral 1 over u du. And what's the integral of 1 over u? Natural log. Now I got to put it back in, yeah. Technically, I would not have to put absolute value bars around it, but they're not wrong, so you can leave them on there if you'd like. In this case, you can remove them if you'd like to. Another tool, yes, ma'am.
So, since you're pulling x out of the equation, wouldn't you have to add a plus c to that?
I would. If you'd like to, I could add a plus c here. And then I'd add a c plus c, so that would be... No. Because these c's aren't the same. So you want to play that game, you're going to have to write c1, c2, and make this a c3. But notice the silliness. Yeah, notice the silliness. This is just a constant, right? It's a number. I'll grant you that the number that would be here and the number that would be here would not be the same as the number that's here. But does it matter? I haven't told you what c is to begin with, right? So it's some random constant. So c plus c is c.
Okay.
That's why we do it that way. Now, it's sick and wrong. I understand. But it's also fun. Everybody start working on some problems.
Are we working on 8-6 now? Or?
Yeah, go ahead and go 8-8 now, if you'd like. And actually, you know what? Start on the back. It'll make you happier. Start on 3. Well, here's the deal. Try U substituting. When it fails, what else you got there? No, you're going to say, I'm going to try U substitution. I'm going to try to resolve this like I always know how to do. I'm going to try factoring maybe even. At the end of it, though, you're going to go, oh, none of that worked. I guess I'm going to have to use a long division problem. So you're using your classical student problem-solving skill of, hey, this is a long division worksheet, so you can probably do long divisions. I should have paused this already. Oops. Negative 4x minus 4, change my signs. I get 6. What times x gives me, I heard a what? You're good? What times x gives me 6? Nothing gives me that, so I'm going to go ahead and write this as a fraction. 6 over x plus 1. Now all I did is reform my problem so I can do the integral. So now I'm going to do the integral of x minus 4 plus 6 over x plus 1 dx. Integrate a piece at a time. 1/2 x squared minus 4x. Plus, or integrate this, I'm going to need U substitution, aren't I? So u equals x plus 1. So du equals 1 dx. So here we make the top 1.
Yeah.
How would you like to do that, Mr. Dietz, since you said yep?
Divide by 6.
Divide by 6. So if I wanted to, I could either pull the 6 out, or I could divide this by 6 inside and multiply by 6 outside. Which way would you like to phrase so we get a 6 outside?
I pull the 6 out.
Pull the 6 out. Love it.
1.
And then that gives me the 1 dx I wanted.
Yep, that's it.
That sets me up for u substitution. Oops. Minus 4x plus 6 ln of absolute value of x plus 1 plus c. And I'm done. Yes, ma'am.
Can I screw myself over by looking at the 6x plus 1 and going, okay, the integral of that is 6 natural log of x plus 1?
No, you're not, except watch out for if this becomes a 2x or an x squared. Why?
It just needs to be.
Because you're going to end up with a weird factor popping up. In other words, when you go to do u substitution, if this is as long as it's a 1, life is good. If it's something else, then you have to have u substitution well. It's the only risk. You should at some point get. I mean, I'm looking at this problem. When I get it to here, there's no way in heck if I was doing this on my own, I'm actually doing all these steps, right? You can run through that 6 over 6 ln of x plus 1. Now just watch out. If it's a 2x, I'm going to have a 1/2 out in front because I needed my u substitution to be slightly different. But
It's anything other than singular x.
right. Then you probably should bother to write down the u substitution step for a couple more times, and then down the road you're going to be like, this is easy. Don't worry about it. All right, blow through the rest of these. Let's go. Mr. Cleary, I don't know what you're doing, but it's probably not math.
Who's that? This is on whole bread.